Part 3 of 3, Alkanes and Alkenes. In this part 3, you can learn about how alkenes are being produced by cracking, comparing alkanes and alkenes in terms of structures and their reactions, as well as a little bit of information on fats and oils. So what is cracking? This is a very important definition of cracking. Cracking is a breaking down of a long chain hydrocarbons into smaller hydrocarbons or hydrogen. And alkenes are obtained by cracking petroleum. For example, hexane is a larger molecule, C6H14. When cracked down, it breaks up into two different molecules, C4H10 and C2H4. Take note that the number of carbon before reaction is 6, and after reaction, the total number of carbon is still 6. As well as hydrogen before reaction is 14, after reaction is still 14. The reaction of breaking down one large molecule into two or more smaller molecules is cracking. In catalytic cracking, a catalyst is used to speed up the process of cracking itself. These are the industrial conditions for cracking. First, high temperature. Take note, high temperature of 600 degrees Celsius and catalysts, aluminum oxide as well as silicon dioxide, they can be used as catalysts to speed up cracking. So a long chain alkane or long chain hydrocarbon is broken down into alkenes, shorter chain alkenes, and another shorter chain alkanes or even hydrogen gas. This is a cracking of hydrocarbons in the school lab. The glass wool is soaked with liquid petroleum, for example, kerosene. When heated, the liquid petroleum becomes vapor. As it passes through the catalyst, of course you must heat the catalyst. As it passes through the catalyst, which is made out of the broken porous pot, and they contain aluminum oxide or silicon dioxide, this liquid petroleum, which could be kerosene, is broken down into gaseous alkanes and alkenes. And since a gaseous state at room temperature and pressure, we can know that they are actually smaller molecules. Why is cracking so important? Because cracking can produce short chain alkenes, and alkenes are being produced by cracking of alkanes. Alkane is obtained from petroleum. So you do not get alkenes out from the ground directly, but instead you crack alkanes to form alkenes. For example, this C18H38 is cracked to form C2H4, which is ethene. And short chain alkenes such as ethene and propene are commonly used to make ethanol and plastics. They are very useful to make plastics and so on. Cracking can also produce hydrogen. If you remember Haber process, cracking produces hydrogen that's needed in Haber process to produce ammonia. For example, in this cracking, hydrogen is produced as one of the products, as well as shorter chain alkenes. Hydrogen is used in the manufacture of ammonia gas, which is then used to make fertilizer. Cracking converts hydrocarbon of higher molecular mass into smaller molecules which are in higher demand. For example, there is higher demand for petrol than lubricating oil or diesel oil. Hence, petrol can be obtained through cracking of this larger molecule of diesel or lubricating oil. Let's try this question. Liquid alkane heated strongly, and aluminum oxide heated strongly also. So what is the process that we are getting here? That's right, it's cracking. Cracking of hydrocarbons breaks them into smaller molecules. Which example of cracking will produce largest volume of product? Largest volume of products from 1 mole hydrocarbon. So all measurements are made at the same temperature and pressure. So just check that, make sure everything is starting with 1 mole. And of course, make sure that the states are gaseous states. So the largest number of mole, of course, answer is A. Because A, there is 3 mole of ethene and 1 mole of hydrogen. So a total of 4 mole. As compared to B, total of 3 mole. 2 plus 1 is 3 mole. and C is 2 mole, and D is 2 plus 1 is 3 mole. So answer of course is A. Next question. When 20 cm³ of gaseous alkene burns in excess oxygen, 60 cm³ of carbon dioxide are formed. So what's the formula of alkene? First, try to write equation. Because we do not know what's the formula of the alkene, so it let it be CnH2n plus how much oxygen I do not know either. But I know the volume of alkene is 20 to 60 cm³ of carbon dioxide. So I know ratio is 1:3, so I can write 1:3. From this equation you can see that the number of carbon is 3 carbon in the carbon dioxide. So hence on the left hand side they must have carbon, 3 carbons. So answer should be C3 because N must be 3 in this case. And of course answer must be A because C3H6 is the answer. Next we compare the alkenes and alkanes. And this section is very important, so make sure you remember them well. Describe the difference between saturated and unsaturated hydrocarbons. And saturated is represented by alkanes, unsaturated represented by alkenes. Both alkane and alkenes are hydrocarbon. Why? Because they are made of hydrogen and carbon only. They are all flammable, they burn completely to form carbon dioxide and water when there is excess air or sufficient oxygen. When there is insufficient oxygen, it produces carbon monoxide and water. Now, very important, the differences. Alkane contain only carbon-carbon single bonds. Alkene carbon-carbon double bonds. And remember, every alkene has only one single carbon-carbon double bond. So you can only see carbon-carbon double bond existing only once inside any alkene molecule. And because it does not have double bonds, alkenes are unreactive. Alkenes are very reactive because of the carbon-carbon double bond. Alkene can undergo substitution reaction. Alkene can undergo addition reaction. And the very key difference between addition and substitution is addition is a very fast reaction, spontaneous. Substitution, there must be presence of UV ray, and the reaction is very, very slow. Alkane does not react with bromine water under normal condition. In other words, without UV ray, it will not react. But alkene rapidly decolorize aqueous bromine. Alkane less smoky flame when burnt. Alkene will be smokier. As we mentioned earlier, alkene has higher percentage by mass of carbon. Higher percentage by mass of carbon in the molecule, hence it burns with smokier flame. Alkane does not undergo polymerization. Alkene undergoes addition polymerization. Let's try this question. Which of the following reagents can be used to differentiate a sample of propane from propene? Now this question also can be phrased in a way to differentiate a sample of saturated from unsaturated hydrocarbon. So of course is bromine water. Propene will turn it from reddish brown to colorless rapidly. Last, fats and oils. We need to know the term polyunsaturated. We learn about unsaturated containing carbon-carbon double bond. So what is polyunsaturated? And also able to describe the manufacture of margarine. So polyunsaturated fats or oils, they are polyunsaturated if they contain more than one carbon-carbon double bond. So keyword is poly means many, and unsaturated means carbon-carbon double bond. So this means unsaturated, and poly means more than one. So a polyunsaturated compound contains more than one carbon-carbon double bond in the molecule. In this one single molecule, there's carbon-carbon double bond, another one, another one, another one. There are 4 carbon-carbon double bond. How to make margarine? Margarine is made from vegetable oil. The condition is very simple. You heat vegetable oil with hydrogen with temperature 200 degrees Celsius and nickel as catalyst. N-I-C-K, yeah, nickel as catalyst. And you produce margarine. Now, basically, margarine is a saturated fat. Margarine is a saturated fat, and vegetable oil is polyunsaturated. So, with all this carbon-carbon double bond, when hydrogen is added across the double bond, you get saturated fat, and that's margarine. The more saturated the margarine, the harder the margarine. So what's the difference between fat and oil? Fats are solid at room temperature, oils are liquid at room temperature. And fats are mainly saturated, while oils are unsaturated fat molecules. So the difference is, when it's saturated, it becomes solid, and that's fats. And when it's unsaturated, it's liquid, and they are oil. That's the end of part 3 of this video. Hope you have understood alkane, alkenes, their structures, their properties, as well as their differences.